Hello. This is the introductory content lecture for the Art of Science segment of this learning community. It's anchored in course Mathematics 1340, the history of math. The topic today is Why is Math a Special Science, Part 1, and I encourage you to use these controls in YouTube to perfect your understanding. In this course, we will talk about some big questions, including what is math and what is science, and why should we care? A step towards some of those answers will begin today. I observe that both math and science involve blood, sweat, and tears, but today's discussion will include no blood, but the other fluids will be available. You will watch my video to a point and then launch another BBC video. After the BBC video, you will write and submit to Blackboard 1-paragraph answers to 4 questions based on the BBC video. Not a lot of writing, but some thinking. You will then resume my video wherein I will share some of my personal thoughts about the video, math as a special science, and life in general. Remember, as you watch these videos, the basic course covenants. You don't have to understand everything. No one does, and no one expects you to. You all will be asked, however, to think critically and to share your reflections. And your learning and contributions will be open-ended and flexible. Success may be different for different students, but all can succeed. The questions to be answered about the BBC video begin with a preamble of, what do you think? That means you cannot be wrong. First question is, where was the sweat and where were the tears? And why is there sweat and why is there tears? The second question, can you think of a famous historical figure who cried in a similar setting? Explain your answer. The third question, how are great athletes and great mathematicians alike? And the final question, probably the most significant, is what does this proof business mean to you? So the balance of this lecture, you're going to watch the BBC video, keeping the course covenants and questions in mind, jot some notes along the way, answer the questions and submit your answers, and return to my video for my answers and closing remarks. Okay, so pause my video. This is the link you do, and you'll return to my video at the end. Really, watch this video. Here's the hot link. Welcome back. Like most of the time, this movie was based on a book, and Simon Singh wrote a book called Fermat's Last Theorem. I read the book before I watched the film. It's a good book. Here are my answers. So where was the sweat and where were the tears, and why were there sweat and tears? Well, hundreds of mathematicians worked hard for over 300 years to solve the problem and failed. Their work was their sweat, and their failures spawned their tears. Andrew Wiles cried because he realized he had solved a problem no one else could, and it took him his entire adult life to achieve this feat. And he would never achieve anything so great again. These were tears of joy and tears of sadness. From famous historical figures who cried in a similar setting, I think of Alexander the Great, who conquered the entire world at age 33. He cried because there were no other countries to conquer. His grief was so deep, he took his life at a very early age. Similarities between great athletes and great mathematicians alike. Both seek specialized recognition and fame. Both experience the thrill of victory and the agony of defeat. And the most deep question is, what does this proof business mean to you? This is what it means to me. It is the tradecraft of professional research mathematicians. It is complicated far beyond one paragraph, but it distinguishes mathematics from all other sciences. An example follows of a proof. The figure of merit of a proof is what is that you are convinced of both the result and the technique. Another figure of merit is that it is pretty. So let's begin, as Weil did, and sort of be stumbling around in a dark room. So we observe that if I add these numbers, I get 10. If I add these numbers, I get 15. And if I add these numbers, I get 21. I stumble around some more, but eventually I start knowing where the furniture is, and I observe there seems to be a pattern. This sum is given by this. The second sum is given by this, and the third sum is given by this. This involves what we refer to as inductive reasoning. I am generalizing from some select examples. And there can be many such examples, but we never cover all the numbers. That's what the ... stands for. But we could conjecture, based on this, that if we took any number n, I could add up the first n numbers, thank goodness for ... and I can get n times n plus 1 divided by 2. Now this is where math differs from science, because we don't just make conjectures, we seek to prove the conjectures. So this is the conjecture we're trying to prove. So where's the proof? Note that the proof involves deductive reasoning, logic, and known facts. So we define what we're trying to prove to be n times n plus 1 all by 2. We define that to be s, so we write this down. Note that it is useful for us to, in addition to just the ... include this thing. And then what we'll do is we'll say, oh, if I write it backwards, instead of adding 1, 2, all the way up to n, I add 1, 2, all the way down to n, I get the same thing. So if this is s, then this is s. Now I'm going to add these two equations term by term, that is vertically. So s and s is 2s. I add this one with this one, this one with this one, this one with this one, and this one with this one, and all the ... in between. Now here I get 2s, but each one of those sums to n plus 1. And how many of them did I have? Well, that happened n times. So you see 2s is equal to n times n plus 1. We divide both sides by 2, and we get s is n times n plus 1 all over 2. This is concise, creative, convincing, and for me, beautiful. G.H. Hardy, a mathematician that we're going to talk a great deal about, who wrote a famous essay called A Mathematician's Apology, said, "The mathematician's patterns, like the painter's or the poet's, must be beautiful. The ideas, like the colors or the words, must fit together in a harmonious way. Beauty is the first test. There is no permanent place in this world for ugly mathematics." You see, math, a science, is an art form. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of others.